Hi guys, Arthur D here. So now on this video I will show you how you can use the Ultimation extender to probe the CI bus. I must warn you, this video will be a bit longer than the other ones because explaining the CI bus, how it works, it might not be easy and a bit complex for some of you guys, especially if you don't know how the Ultimation works. So I will try my best, so please bear with me. The CI bus, or CA computer automation bus, I was saying it wrong, is something new that the VCA fader consoles didn't have. Basically, it's an 8-bit port for reading and writing control status between the fader and the computer. So on the VCA faders, what you had, everything was analog, and the computer was controlling things like the LEDs, the status button on a card which was called the lights and switches card. On the Ultimation, this works very differently. The computer, instead of the lights and switches card, has a new card which is called the CA bus card. This is actually the card that runs this CI bus. This card basically uses an 8-bit port for reading and writing status on these Ultimation faders. Things like which the computer can read through this port are like the touch sense, the status button. When I click, it's a bit. Stuff like the stall, if the motor is stalled and can't work. The thumb wheel coding, it's all read through the CI bus. To write, it writes stuff like, let me see, the LEDs, which LED is lit and which one is not. If it's motors on, motors off, if it is on the VCA mode or Ultimation mode. Also, if you have to cut, like mute the fader, this can be also automated through the CI bus. So on the VCA desks, this was all done through analog. On these on the Ultimation, this is all done through this digital bus. As you can see on the fader, this is very different from the VCA one. On this fader you have two cards, which is called the 352 card and the 353 card. The 352, it's the control card. This is the card that handles the CI bus on the fader and controls every aspect of it, like the LED, lights, the LEDs, all the logic stuff is all done on this card. The other card is the DC servo card. This card will handle all the motor driving, the audio level. All those things are done on a separate card. Okay, so you can see here I made two small tables that show you how this 8-bit port is configured. So when the computer is reading from the fader, this is the 8-bit configuration. So the first 4 bits, they will codify the thumb wheel number. The 4th bit will be the status, this button. The 5th bit will be cut switch, the 6th servo fail, touch sense. Okay, so this is the configuration. when it's writing, you have like TR select. So if you are on total recall mode, you have to, this bit is enabled. You have the LEDs, the trim, alt, and absolute. Absolute is something also new on Ultimation, which there wasn't on the VCA faders. You have the solo isolate. Let's not go too deep into this, but you see there are two different configurations between read and write. I will also try to show you here. It's not easy to handle the camera and show you. This is the schematics for the 352 control card, and here, I hope you can see here, this is basically the bus. So you can see if it's read, you have group bit 0, group bit 1, group bit 2, but if it's write, you have TR select, ABS LED, trim LED, mix LED. Actually, these are not correct. This is something I discovered, and it's fixed on the Ultimation extender. But the order is not this one of the LEDs. And here you can see, let me try to show you. So you have one IC, which is the bus driver, that controls the reading. So when the computer is reading the status from the fader, it uses this IC. And you can see it if you go, for instance, go up here. This is the status, the thumb wheel switch, and this connects. Oh, I'm sorry. This is very sensible. Okay, try again if I can find it. I'm sorry, but this is not very easy to drive. Okay, so the thumb wheel connects to this bus driver chip, and when it's writing, instead it goes to this chip, which is a D-type flip-flop, and this will set stuff like the LEDs, for instance. Okay, and to control how these both chips are working, you have these control signals, which is the read signal, the write signal, and the channel select. Okay, so what I did, I know this is not easy to explain, but you really need to look into the schematics to understand it, but I think I gave a pretty good explanation, and now it's more easier to understand this jungle cable you see on the extender card. I have here an extra extender card so you can see what I am doing. So what I did exactly to probe all these signals is I connected the oscilloscope probes into the read, which is this one, and the write, to see when I was reading or writing. And then I also grab this channel select. Then I use the digital probes to get the bit 1, bit 2, bit 3, bit 4, 5, and so on. Okay, and you have everything here. So this is group bit 1 on reading, on writing is TR select. For instance, here you have status switch for reading, or if it's writing is solo isolate. So you can, it's really easy to find the signals here. And after connecting everything, this is what we got. Okay, it's a bit confusing, but I assure you it's all in there. Okay, so now I will fire the oscilloscope, which is this screen, and I will load channel A, and channel A is, let me check it, is the read. Yes, it's the read signal. We just trigger it. I'm going to trigger this, so repeat. I'm going to trigger it on the upper, and this is fine. Let's decrease the precision. So here you can see the read. Let me just increase the zoom. So this is the read signal. Now I'm going also to probe the write signal. Okay, so it's easier to see. So when it's reading, and this read write is active low, so when it's on 0 it means that it's active. When it's on 5 volts it means it's inactive. So here we can see in blue you have the read is inactive but the write is active. So on this time the computer is writing control bits, and here where you see the mouse you can see that the computer is reading from the fader the control bits. Now let's try to see which bits. Okay, so I'm trying to do this with one hand, sorry. Okay, have bit 0 to bit 7, and also I will get bit 8, which is the channel select. This one I will put it up there. I will rename it so we can see easier. Select. Okay, apply, and we're done. Okay, so you can see here all the bits changing between read and write. This is not triggering correctly, so it's a bit dangling, but let's focus here. I will try to center it better. Okay, I will also increase. Okay, so I can show you how this works. You see here you have the, let's say this is reading and this is write. So in this interval, let's just mark it so it's easier to see. See if I can. Okay, between here and here the computer is writing status into the fader. So let's try to see an LED being lit. Okay, so we are going to lit the ABS LED. ABS LED, accordingly to our table is the D2, okay? It's bit number 2. So it should be D2, it should be the green one, which is low. You see here? It's low. Okay, change here. I have fired the test procedures. Okay, I hope you can see it. I don't know. But I will turn on the ABS LED. It's on. Okay. ABS is now on. Trying to focus, I'm sorry. Okay. And we have D. It's 0, D1, D2, D3. It's on. Okay. I'm going to try to disable it while I'm filming, which will not be easy. But okay. You see? On, off. Yeah. So now, instead of the writing, and with this you could really test everything. So if I'm going to enable motors, disable motors, it will show everything here. Now let's go to the write. Sorry, to the read. I'm going to check it. Trying to find the read phase. It's not here. Read starts here. Sorry. Okay, I've got it. It's around here. So now focus where I have these lines. This is where the computer will start reading the control bits from the fader. I'm going to increase a bit the resolution so we can see better. Okay, so let's see which one is touch sense. Touch sense is bit 7. Bit 7 is here. It's the purple line. Okay, I'm going to touch. Whoops, it's there. You see? Touch sense is working. Now I'm going to see the status button. Okay, status switch is D4. Okay, so D4, it's the purple. Also, the other one was pink, more pink than purple. Okay. Let's see. Sorry, it's not easy. Okay, can you see it? I'm pressing the status switch and it's changing. Okay, so I think I was able to show you how you can use the SSL Ultimation extender to probe the CA bus. Look to the next videos where I will show you more stuff you can do with the extender, and see you soon. Cheers.